Alright, so the class is on the boards right now, showing what they know about just finding these little ratios of values for trigonometry. Uh-oh, hit the wrong thing there. Sorry about that, everybody. There it is. That's what you should have got. One thing you should have last year is not only just SOHCAHTOA, but also the introduction of secant, cotangent, cosecant, the reciprocal of sine, secant, the reciprocal of cosine, cotangent, the reciprocal of tan. All right. Okay, solve for x. Only put it in calculator-ready form, though. So don't bother going to get your calculator. Just get it in calculator-ready form for what you would have to type anyway in order to solve this scenario. Go ahead. So, make the adjustments. Yes, I am writing. Good. Look up here. Shh. This is the adjacent side. 225 degrees. This, no matter what, is the hypotenuse. What deals with adjacent hypotenuse? Cosine. You know ca. Okay, so, but how do I get x by itself? I don't know. The algebraic way is to multiply both sides by x first, then divide. So, majority of you do have that. This is something you'll have to do, I don't know, throughout the chapter, or actually throughout this book. Do it again. Okay, next person. Look up here. So, what side is this, everybody? Shh. Opposite. What side is this? That's TOA. But what you tan is the angle measure. So, unfortunately, this one, we have to find the angle from two sides. Half the group's got this figured out, that you inverse tan the ratio to get the angle measure. All right, so that's the correct thing that we should have for that. Last one, just for more giggles, and then we'll have a seat. Most are done. What side is this? What side is this? And what's this? What deals with opposite hypotenuse? But you sine the angle, and that equals 11.7 over x. Yet again. Okay, one thing I told my students after doing this a long time, what can I do when x is on the bottom and sine 55 is here? Just switch them. Okay, I don't know what you need to do, but some of us got to figure out how to do that when we actually do these basic trig questions. Okay, have a seat. Okay, so at least demonstrate that you know SOHCAHTOA, right? You know that you sine the angle measure to equal the ratio of sides, opposite over hypotenuse in that particular case. But all we're going to do is stretch this out a little bit. So I'm going to blabber as you write this down. What's going to change right away is really all we're going to do is put these triangles in a coordinate plane. We're going to call this now coordinate trigonometry. What's odd about this is, look at this triangle as our first discussion. What kind of x value? Negative y value. So you're going to have negative side length. That's going to be strange for you. And that's algebra 2/cat trig. It actually turns into what's called circular trigonometry. We're going to have something that's called a unit circle. And the reason I bring that up, look at what letter I changed hypotenuse to. What's underneath hypotenuse in purple? R. So I call it circular trig. What's in a circle that starts with R? It's very important. Radius. That's what that R actually stands for. That's just to give you an idea. Don't try to understand it right now. So, we're going to get to this right away. The quicker you get to this, you know what I'm going to say next, the better off you're going to be. So, what? So, will now change to, do you remember? No. It has to do with I changed to SOHCAHTOA last year. I mean, you don't. Oh, yeah. All right, because look at this triangle. By the way, when you draw a coordinate, what coordinate do you do first, x or y? X. So that's how you're going to draw these triangles. This drives, I tell you what, I will mark you wrong so quick your head will be spinning. When you draw a triangle and it touches the y-axis, whenever you do this, you instantly get no credit. None. Because what coordinate do we do first? X, then what? Y, and then what we do is we come back to the origin. So when I give you a coordinate, you make the triangle by actually drawing your coordinate. X, Y, that's your pencil. And then R, or the hypotenuse, is you just snap back to the origin. So if you can do that, then the trig that you do next is just as easy as what we did on the board. I'm telling you. Okay, so that's what we have to do. By the way, up in this corner, I thought it'd be nice that we share some common Pythagorean triples, because what kind of triangles are we dealing with every single time? Right. So our book is obsessed with using these four little triples to save you some time and work. But if you don't know these triples, then you always have to use the Pythagorean theorem to find these values. So mark them down. Everyone in the world better know 3, 4, 5. What does that mean, 3, 4, 5? 3 squared, keep going, plus 4 squared equals 5 squared. Who's the hypotenuse in this last one, 8, 15, or 17? Come on, 17, it's the biggest side. Okay, so what did I say? Read this thing up at the top, trigonometry. That's just our little introduction. You've already done trig once or twice, 2 different classes. Trig is the magical algorithms that allow us to relate side measures to angle measures. We can find side measures from angle measures. So that's what the magic is behind trigonometry, and vice versa. By the way, look, I did say one of the weird things we're going to have is sometimes we'll have negative side measures, but make a note to self. R, or the hypotenuse, will always be positive. The only reason x and y may be negative is that it depends what quadrant you end in. Say you had a coordinate in quadrant 3. What do you know about x and y in quadrant 3? X and y in quadrant 3 are what? Both negative. I'm starting to lose fifth hour, just like I lose first hour every day. Snore, snore, snore. Got it. Focus. It is the key to understanding actually a huge part of this book. The quicker you get this paragraph or whatever you want to call it figured out, the better off you're going to be. So, given any coordinate, a right triangle can be created. I just talked about that. You do x first, then y, and then you snap back to the origin. All right? The angle theta, stop. Look up here in this drawing. Here's theta. Remember standard position? Let me do a highlighter so you know where I'm at. Standard position, we always start at the positive x-axis, and then we have a terminal side somewhere. I just happen to have an example that's what theta creates. That's theta. But what it creates is what's called theta prime, which is called a reference angle. And that's the one that actually you can get away with playing SOHCAHTOA with. That is the angle. That is the key. The problem with SOHCAHTOA is, you're not going to believe this, you actually will not get a triangle at some points. So if you have no triangle, you can't play SOHCAHTOA, right? No triangle, no hypotenuse, no sides, what am I doing? So that's why the next thing we're going to have to do, or I'll show you, you'll have to do. Notice, I even have this written in my little, colored up little paragraph here, that no matter what, here's theta prime. Look at x. What does x represent for theta prime? What side? Everyone read that word right underneath x. Adjacent. And then look at theta prime. What does y always represent? This isn't always. This is not just this one example. When you do coordinate trig, you do x, comma y, and then you come back to the origin. When you draw your triangle the right way, x is always the adjacent side, y is always the opposite side. The hypotenuse will now be called r for radius. And you don't understand that quite yet, but it is what it is. So, what sign? I'm going to just do this right now before I show you the next thing. Sine is, opposite over hypotenuse. But instead of so, it's now called sir. Sir. What's cosine? Ka. Oh no, it's kixer. What's tangent? Choa. Oh no, it's tix. Sir, kixer, tix is the new acronym that you need to learn in Algebra 2. So instead of SOHCAHTOA, here's sir, kixer, tix. Someone looks like they think I'm an alien. So again, I don't care how you look at me, I know I'm weird. You started to live with me like my family, huh? Eat dinner with me every night. But you have to get this figured out that so turns into sir because the y is always the opposite side. The hypotenuse will now be called r. So, no, sir. Ka, kixer, because x is always the adjacent side. Toa, no way. Tix. Sine is so, cosecant's a ho. So that means sine is, what? Let that one slip in there. Sine is y over r, so cosecant's r over y. Cosine is ka, so secant's a. Or it's r over x. And then cotangent is the flip of tangent. Yeah, you gotta be ready. It's taking too long. All right, here we go. First example shoved right in your face. Right in your face. Okay? The answers are all here. This is your job. You had to come up with these. Okay, but it's too early. Don't look at that yet. Try to look at this globally, what you had to do. Let's zoom in on the words. Okay, the terminal side of an angle in standard position. Let me just have that and then focus on the drawing and nothing else. If I could stop moving this around or move it appropriately. The terminal side of an angle in standard position. Stop. Standard position means the opening side or the starting side is the positive x-axis. And the terminal side passes through 8, 15. So that's what you do. Oh, okay. 8, 15. And then you jump back to the origin. And that's how you draw your triangle. You don't do that, you're done. And I get it all the time. I get some students in CAT from 2 years ago that even by February, what's with that R in there? February, they're still drawing triangles touching the y-axis. You will fail so quick your head will be, anyone? I don't understand it. This is coordinate trig. You do x first, then y. I'm done with it. Okay, so guess what? Theta is the angle, and it actually is the reference angle. I know that's a new word for you for the day. So that's the one we can play SOHCAHTOA with. What's 15 represent? 15 represents what? You can do opposite. You can get away with it. Don't be guilty about using SOHCAHTOA still. But what you need to do is keep understanding the opposite side is what? And you already said it. Why? Because you have to use sir, kixer, tix in certain examples. 8 is adjacent, and then 17 is the hypotenuse, but we call it r and adjacent x. So you better get used to doing that. Sir, kixer, tix. You could survive with SOHCAHTOA though. So I'll just stop the video and let you take that down. Here's another example. Again, let's focus on not the answer, but the directions and then the drawing. So focus on it. The terminal side of an angle in standard position. Stop. Standard position starts at the positive x-axis, and then the terminal side happens to pass through -3, comma, -4, and then 5. Because this is a Pythagorean triple, you snap back to the origin to complete the triangle. So you do this, -3, -4, and then 5 is one of those triple values, or use the Pythagorean theorem if you can't have that remembered. But here's where I want to make a point. This is theta. Oh, sorry, it's already drawn here. Hey, just look at that drawing. What's theta between? What measure is theta between? 180 and? You are correct. So you're actually finding the trig of an angle greater than 180, but between two, but less than 270. That's theta. Here's theta prime, though. What's theta prime between? What's theta prime between? This little angle here. Not 180 and 270. Theta prime is actually between 0 and 90. Okay, it's just that little angle in there that's part of this triangle. That's the angle you can play SOHCAHTOA with. So, what side is this? What side is this? Or, we're close to a holiday. What side is this? What side is this? No? All right. Opposite. What side is this? You don't get it? What child is this? Never mind. It's public school. Opposite adjacent. What's this? Hypotenuse or R. Yeah, get used to it. And then I'm probably going a little slow on this. Jump back, and then the next one will be blank. So there you go. You get sine of an angle measure, and what kind of answer do you get? Starts with an N. Negative. That's the first time in your life that's ever happened in trig. It's because we are in coordinate trig. So circular trig is what this is eventually going to be called. A circle in a coordinate plane. Kind of trigonometry. Okay, blah, 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 blah. Feel free to read all of those. You know, they are very lengthy on the directions, but a lot of times in the directions they tell you how to do this stuff too. So I love this book. So here's what's weird about this. This is not a typical coordinate that you're used to dealing with. So -1, comma, √3, and then snap back to the origin. By the way, does anyone know the third side? This is a very popular kind of triangle. 2, and then he just said 30, 60, 90. It's amazing. We're not supposed to be doing that yet, but it's true. I actually know what that angle measure is right there, that reference angle. What is it? Those that said 30, 60, 90. It's actually the 60. So I don't want to confuse you because you're not supposed to be finding angle measures here. And those that don't know this, don't panic. Although you should kind of remember this from geometry. We're actually finding the sine, cosine, and tangent of 120 degrees right now. How do I know that's 120? Because that's 60 away from what? 180. So we're actually doing that. Those that know that this is a 30, 60, 90. Those that don't, forget that just happened. Square root of √3 squared. What's √3 squared? 3. -1 squared. What's -1 squared? What's 3 plus 1? What's the square root of 4? That's why that's 2 there. All right, this is x, which is adjacent. This is y, which is opposite. And then this is hypotenuse, which is r. Okay, so what's the sine of theta, everybody? What's the sine of the 60 in quadrant 2? Ooh, sine is √3 over 2. It's not negative because we're up √3. Yeah, you did. Cosine of theta is what? Adjacent over hypotenuse. -1 over 2. Tangent is what? Y over x. -√3. Everyone okay? Get some action. Are you done with all those? Oh, yeah. I'm behind here, huh? And then what's √3 over 2 flipped? I am going to mark you wrong so quick your head will be spinning. Why? What do you got to do with 2 over √3? You know what? Rationalize. What's √3 times √3? Get used to it. And then, I got to do it again. And you're going to do this so many times that you should know that this is going to be -3 over 3 eventually. Okay, so you're going to rationalize so many times in the beginning of this chapter that that should come quick. Maybe not yet, but eventually. So how is that 4? We just talked outside of the computer here, or YouTube, or whatever you want to call it, that this is a 30, 60, 90 in the skies again. Those that don't know that, no idea what I'm talking about, a little upset that you don't remember your geometry, but don't worry about it right now. Oh, that's a negative. But a negative squared is always a what? What's negative 2 squared? 4. What's negative 2 squared? Say it again. 4. But what's root 3 squared? 4 times 3 is? What's 12 plus 4? What's the square root of 16? 4. So that's how you get 4. Just showed you. And then after that, it's over. This is x, this is y, this is r. So instead of SOHCAHTOA, I'm going to play Sir Kicks or Ticks. Sine is y over r. I'm pointing at it because I'm letting you just let it sink in. First hour, I asked people, and it just took too long. So hopefully you understand what I'm doing. Cosine is, and again, sorry, this is theta. This is theta prime. I put it real small in there. That's the one we play SOHCAHTOA with. Opposite, adjacent, hypotenuse. You can get away with 90% of this book by still playing SOHCAHTOA. The one coming up is the one that you can't, and I'll show you what that is. But anyway, x over r is negative 2 root 3 over 4. Does this reduce? Answer the question. Yeah, the answer is yes. It's negative 3 over root 3 over 2. Tan is y over x, so it's negative 2 over negative 2 root 3. Does anyone know what this becomes? Boom, boom. So now this is 1 over root 3, which is root 3 over 3 when you rationalize. Get good with rationalizing. This is easy to flip. This one is not as easy to flip because we have to rationalize, but this is what I'm talking about. You're going to do this so many times that rationalizing better not be the thing that holds you up in trig. And then don't flip this, flip this. What's 1 over root 3 flipped? Just root 3. That stinks to flip. Got extra math there. Oh yeah, no SOHCAHTOA. You know why no SOHCAHTOA? 0, comma, negative 4 gives you no what? No triangle. So here we go. 0, comma, negative 4. And then what are you supposed to do to get the r value? You snap back to the origin. What's that distance back to the origin? 4. So that's why that r equals 4 came out of my brain. Or, if you want to be a robot and just do what the, Pythagorean theorem, you're going to get the square root of 16, which is 4 anyway. Again, you do x, comma, y, and then you snap back to the origin. This one you should be able to count that it's just 4 back. So that's why r is 4. See how we can't play SOHCAHTOA? There is no triangle. So you're stuck with Sir Kicks or Ticks. By the way, what is this angle measure? Everyone in the world should be able to figure out what this angle measure is that we're actually finding. We're finding the sine of 270 right now. What is the sine of 270? But you don't have to worry about that. What's the answer? For the love of whatever you believe in, it's just y over r. Y over r. What is it? Negative 1. It's negative 4 over 4. I'm going to go crazy. Huh? Who said how?
What? No, I said how.
Oh. Cosine of 270 is what? 0 over... Okay, I'm going to write it because some people question themselves, is this undefined or is it 0? It's 0. I'm not going over that anymore. Tangent is negative 4 over 0. What's that? Undies. And then, what's the flip of negative 1? Negative 1. What's the flip of 0? Ooh, that's undefined. Absolutely. Undies. What's the flip of undies? 0. The whole point of this page is how do you deal with those angle measures that land right on an axis? You know what you do? You make up a coordinate. This is called coordinate trig. So you make it up and you write it down. All right, and then that's what this on this page. You go ahead and find it in 1.3. They go through all of the quadrantals. I know I'm throwing a word that may scare you. I'm talking about angle measures that land right on an axis. The last one we just did was what? 270. What about 180? You make up a coordinate. I don't care what you make. What's a coordinate that lands on the negative x-axis? Negative 5, comma 0, right? What would your r value be if you're at negative 5, comma 0? 5. But why not just make it negative 1, comma 0? What's your r value then? Sir kicks or ticks after that. I should not have to explain that any further. We can go right to these. Whoa! Just change the game. Look at how long these directions are. Yikes. We can ignore it. You know what you do with this? You draw it. Now, I'm not going to call on anyone. It's your job to pay attention. Plus, we're running out of time. What's 450? Which way do I have to go, by the way? Clockwise or counterclockwise? Now, again, I'm going to 1, 1. It's counterclockwise. What have I done right now? I've done what? 360. How much more do I have to do? 90. So here's that move. I'm right here. I'm supposed to find the tan of this. Boy, I wish I had a... Anyone? Now, I can't help you if you can't find a coordinate and just make up one that falls on the y-axis. What coordinate falls on the y-axis? I don't care which one you used. 0, comma... She said 7. I'm sticking with it. Did you really? Now, it's not what they said to do up there, but what does she have to make her r value then? 7. It doesn't matter. Because what's 1 over 1? What's 7 over 7? You're going to get the same answers. It doesn't matter. See, what they say up here is, just make your life easy and just use 0, comma 1 when you land here. I don't care what you do. As long as it's correct. And by the way, what is tan? What letter over what letter? Sir kicks or ticks. Sir kicks or ticks. Ticks is y over x. That's why I keep saying that. So ticks is y over x. What's 7 over 0? Undies. Again. Okay, then cosecant of negative 450. You got to watch yourself. Which way does negative 450 go? Clockwise. What have I done right now? A negative 360 technically. Then what do I have to do? Negative 90. So I wish I had a... So you make it up. This is your job. The last ones were coordinates. Then you had to find trig. This one is now find cosine, sine, and tangent of angle measures. What's that coordinate? 0, negative... Let's just do negative 1 this time. What's r? R is how far you have to go back to the origin. It's 1. Sir kicks or ticks. Which one is this? Sine is so cosecant's up. No, you don't want to do it? Sine is so cosecant's up. Sine is sir, so cosecant is... yeah. It's r over y. So what's r over y? Negative 1. Oh, I just hit that thing. Now, this is, by the way, this is all no calculator. At this point, you could probably whine that this is no calculator. I think that's a little too much. But I will have this is going to all be no calculator. You got to figure out how to draw these things. This is a little obscene, though. The only reason you need a calculator is 1800. You know what I'm going to divide that by? I'm going to divide it by 360. What if I got a decimal? Lop the decimal off, take the whole number part, and then take that times 360 to find out what's left over. But watch what happens. What does that mean? 1800 is what? 5 rotations. 1, 2, 3, 4, 5. Boy, that'd be fun in the parking lot, right? Okay? I'm hungry. What's that coordinate? What's that coordinate right there? So she's saying 60. It's not negative 10. It's 10. What's r? R equals 1. What's secant? I don't know. I can't see it. You get it? Secant. No. All right. What's secant? What letter over what letter? What letter over what letter? We have no time for this. R over x is correct. Now, you eventually are going to have that memorized. So what's secant related to? Cosine. And cosine is kixer. X over r. So secant is r over x. That's how you're going to have to eventually get there, all kidding aside. So what is r over x? It is 1. That's what the analyzing of that is. And then this is exactly where I ended up with the other class. So you're going to have to focus in, what do we have, 3 minutes, 4 minutes? Oh, it's a lifetime. Some people feel like it is. So now I have to evaluate this expression. Look at the directions. I yanked them right out of the book. It even tells you, hey, whenever you see cotan squared of 90 as an example, what it means is to take the cotan of 90 first and then square it. All this is trig notation, so we don't have to write those parentheses like we do. So that's the one little add-in here. And then this is what I expect you to do with this. Yeah, I expect you to draw the angle measures in question. Why did I only draw 2 of these? Because there is, what 2 angles that we have to find trig for? 180 and 360. 180, I have to evaluate 2 things. So I'm just going to use that drawing once. By the way, 360, what's that point right there? 1, 0 with r equaling what? xy. What's tan? So ticks are ticks. What does that mean tan of 360 is? 0 over 1. So what I'm going to do is replace this with 0. Because that's what tan of 360 is. It's y over x. Plus 4 times. Alright, see what I'm saying? 4 times. Alright, so all I have to do is find the sine of 180. By the way, this is 180. Boy, I wish I had a... What is that coordinate? Negative 1, 0. What's r? xy. What's sine? Sir, kicks or ticks. Sine is sir. So what is sine? 0 over 1, which is 0. And then plus 5 times whatever the cosine of 180 is, squared. That's how you're supposed to analyze what that means. I'd appreciate all of this work. By the way, what is the cosine of 180? I already have it drawn. No, it's not. Cosine is Kixer. So it's what letter over what letter? X over R. What's negative 1 over 1 squared? What is this expression when you're done? 0 plus 0 plus 5. The answer is 5 when you're done. So now what you do is finish it off and actually evaluate. So I got up to 77. You know, your homework, I think, is what this is. So probably up to 79 you're good for. What I ran out of time for were these. Oh, that's actually in the middle, 46 and 50 and 25. No, you might be all right on the later part. So if there's something that doesn't look like it were in the notes, just hold off and we'll talk about it tomorrow.